So again we are going to find out the heartbeat, and this time we are using a different technique. We are doing this by autocorrelation. So this is a sample input. You can look at the size is 150, and here this array is defined for the taking the output. These three variable is for, we will use this in the code. And let's see the serial. We started the serial monitor at the baud rate of 9600, and this, in this code we are doing the correlation, and the output is stored in the yi. After that we normalize this output. Let's see what is happening in the normalization function. So here you can see the one thing is important, that the in the real real signal the peak is come at the zero origin, but here just like we are starting from a zero, so the peak is not actually coming at the exactly at the zero index. So that's why I am finding this max 1, which can be after that the 0, and finding out the max location where the maximum value is coming. After that I normalize this all the output by a maximum value. Again I am showing the, let's see what is output is coming. This is compiling, I'm uploading. So this red signal is our sample input, and this blue signal is our autocorrelation output. You can see the peak is not coming exactly at the 0. Here the peak is coming at some index 10 or something 15 like that. Okay, and after that I am finding out the peak. After that in the peak detection function we'll find out the zero crossing, and after the zero crossing what is the maximum value. So from here we start from the peak, maximum peak, and the second maximum peak, and we will get the time period. So this is Lmax is our time period, and by this 3000 is coming by the sample rate into 60. Our sample rate is 50 here, and dividing that by t naught we are getting the heartbeat. So let me show you how much heartbeat is coming. So 63.83 is coming. Okay, so our next task is that we have to do this all this thing by a real time. So I'm showing you the code. So this is my real-time code. I'm doing the same thing, but here I'm taking the input from a pin mode, that is from A0, and I'm storing the value. I'm storing those value in the val variable, and when the size array will be 150, I will do some process, and the same process I have done in the normal when I have taken the sample input. The same thing I have done here. So let me show the correlation output. So this is my autocorrelation output. You can see that, and it is a normalized. The maximum value is 1. You can look here. And let me show you the output of the heartbeat. So look, 63.22. The next real time is 73.17. Next real time 62.50. So my real time output is coming like this. Okay, so this is how I have done both things, that a real time and the non-real time, by using a autocorrelation function. Thank you.